Hello students, in this video we are going to discuss about vector space. So vector space mainly deals with four important things. Among those four important things there are two sets. So one is we name it as V, the other we name it as F, and then two more things, that is vector addition and scalar multiplication. So what are the things I said? I said about two sets. So let us name that as V and another set as F, and two other operations like vector addition and scalar multiplication. So let us learn about this vector space one by one. So a vector space involves four things, the two sets V and F, and two algebraic operations called vector addition and scalar multiplication. You are all good with vector addition. Suppose if I give you two vectors, how do you add them? So for example, let us take two vectors like this, 1, 2, let us say 3, 4. How do you add these vectors? You add it element wise. So like 1 plus 3 is 4, 2 plus 4 is 6. This is how you add two vectors. So you need this basic knowledge. So anyway you have that. Now it also deals with scalar multiplication of a vector. For example, if I say that x is like 1, 2, so what is alpha into x? It is alpha into 1 which is alpha, and then alpha into 2 which is 2 alpha. So it deals with scalar multiplication of a vector. Now let us also see what is this V and F. V is set of vectors. V is just a set of vectors. So in that V, we have vectors named as V1, V2 up to Vn. So set of vectors is named as that V, and then what is this F? In simple words, for us F means set of real numbers. Let us keep the things very simple. In our discussion, so F refers to set of real numbers. You can also think of set of complex numbers, so that would be a little complicated, but you can take it granted that here in this discussion F for us means set of real numbers. Come on once again. So vector space deals with what? It deals with four things. So first one is V, which is nothing but set of vectors which are named as V1, V2 up to Vn. So next set is F, which is set of real numbers for us. And what is the next thing? Vector addition. And then what is the next thing? Scalar multiplication. So now let us look at what is the definition of vector space. So when do you call a given set as a vector space? What is a subspace? How do you solve problems related to vector space and subspace? So look at this. Like I said, it deals with four things. So what is V? V is a non-empty set of objects called vectors. Yes, it is a non-empty set. Definitely there should be some vectors in it. And what is F? F is a scalar field, and like I said, for us, let us keep the thing simple. For us, F means set of real numbers. So you don't need to go beyond that. Set of real numbers will be okay for you. Next, vector addition, which is denoted as x plus y. So it's a vector addition operation between the elements of the set V. And then the scalar multiplication, where this alpha comes from set of real numbers, and this x is a vector from the given set called V. Okay. So these are the four things that you need to know before you learn about vector space. Now let us look at what is the definition of a vector space. So look at this, the set V is called a vector space over F when the vector addition and scalar multiplication operation satisfy the following properties. So what are they saying? If the vector if the given set V satisfies certain properties which I am going to discuss. So if the set V is like satisfying such properties, then such vector or such set V is called a vector space. So it is a very important conditions, students. So there are two sets of conditions. One is related to vector addition, the other is related to scalar multiplication. Those conditions look simple, but when it comes to solving the problems, you might feel little difficulty. You can even avoid that. You can easily solve the problems. You can overcome that difficulty by solving problems. So in the recent examination, that is GATE DA paper, also you had questions from vector spaces. So you can find questions from vector space in ECE paper as well as from GATE DA paper. So these two streams have this topic. Now, what are those conditions? I want to learn what are the conditions over vector addition and over scalar multiplication. They are very simple, very simple. So, when you see them or when you learn them, they are simple, but when it comes to solving problems, little difficulty you might face. Let us discuss those conditions. So, before, once again, in many of your interview students, when you go for your masters, they will ask you what is the definition of vector space. So, they are so much interested in asking you the definition, then you have to say the set V over F when satisfies the following vector addition and scalar multiplication properties, then such set V is called a vector space. This way of giving them the answer is so important, they will easily take you in the MTech programs. I have seen many professors asking the same question in the interview panels. So, in my interview also, they have asked me this question, they were expecting this kind of answer. So, that is why I am trying to guide you people. Come on, let us look at the conditions over vector addition, very simple. So, let us look at them. Let us see what is the first condition. Like I said, V is a set, you take two vectors from that set. What you have to do is take two vectors from that set, add them. If you add, you get a new vector, that new vector should also be a part of the given set V. So, what did I say? You take two vectors from the set V, add them, the new vector should also be part of V. That is the first property, and this will help you in the problems for verification purpose. So, what it says? X plus y belongs to V for all x comma y belong to V. This is called the closure property for a vector addition. Very simple. You take two vectors from the given set, add, the new vector should also be part of the vector set or the given set. I will take some problems, nothing to worry. So, how to take two vectors from the given set, add them and see whether the new result is it part of the given set or not. How do you do that verification? I will help you, nothing to worry about that. So, when it comes to solving the gate problems, this is going to be very useful. You can easily eliminate the options by using this property. Next, let us see what they say. So, you take three vectors called x, y, z from the set of vectors called V. You take three vectors from the given set and you look at this, x plus y plus z should be equal to x plus y plus z. So, it has to satisfy this. So, this is associative law under vector addition. It has to satisfy that associative law. Next, let us look at the next one. X plus y should be same as y plus x. This is so, I hope this is also very simple. You need not worry about this much in the exam. You need not worry about this much. So, let us look at the next one. So, there is an element called 0 belonging to the given set such that x plus 0 must be x for every x belongs to V. So, what are they saying here? This is a very important property I want to say, or important condition that will be helpful in your examination. 0 vector should be in the given set. If 0 vector is not in the given set, that set cannot be called as a vector space. That is what this point says. There is an element called 0 vector in the given set such that you take any non-zero vector called x and you add with the 0 vector, again you get that non-zero vector called x. So simple. How do you use this for the verification, students? So, you have to check whether the given set contains 0 vector or not. If it does not contain 0 vector, you can eliminate that option saying that it is not a vector space. Yes, this is also very useful condition for eliminating the options. Let us look at the next condition. What are they saying? Suppose you take a vector called x, then minus x should also be present in that vector, minus x should also be present in that set. That is what this says. For each x belonging to V, there is an element called minus x also belonging to the V such that x plus minus x will give you a 0 vector. Yes, this condition will also be useful for verification purpose. Now, students, what you have to keep in mind while solving the problems. The first thing is, if you take two elements in the given set, add them, you get a new element. So, instead of calling vectors, I am saying elements, that is also okay. Let us keep the things in this way. You take two vectors from the given set, add them, you get a new vector. That new vector should also be part of the given set. So that's the first thing that you verify. Next, 0 vector should also be part of the given set. Next, if x is a vector in the given set, then minus x should also be present in that set. So these are the important things that you need to check, and these are very simple. So vectors will definitely satisfy these two things. So nothing to worry about these things. Now let's learn what are the conditions under scalar multiplication. So let's look at these conditions. Now these are not that important, so you can go through them, but for verification purpose, whatever I highlighted, this will be very useful. Now let's look at the properties under scalar multiplication. You take a vector from the given set called V, and you take a let's say real number from F, because we said F means for us set of real numbers. So let's say that scalar be alpha. Let's take a vector called x from V. Now you multiply them. Now you get a new vector called alpha x. If x is a part of V, then alpha x should also be part of V. So once again, if x is a part of V, alpha into x should also be part of V. So where x belongs to V and alpha belongs to set of real numbers. So if that that condition should satisfy. So this is also one of the important things, but so far whatever questions they have asked, those questions can be easily solved with these conditions. So let's look at the other properties. Other properties are so simple. Alpha beta, where alpha beta are scalars or the real numbers. So alpha beta into x is same as alpha into beta x. So for all alpha beta belonging to F and x belonging to V. Next, alpha into x plus y should be equal to alpha x plus alpha y for all alpha belonging to F and x comma y belonging to V. Next, alpha plus beta into x must be equal to alpha x plus beta x for all alpha comma beta belonging to F, x belonging to V, and 1 into x should be x for every x belonging to V. These are all simple, you need not worry about this much. Now what you need to do is you need to check these conditions. Suppose if a given set V satisfies all these conditions, students, all these conditions, then you can call that set V as a vector space. Now any set which satisfies these whatever we discussed properties, that set will now be called what? Vector space. So before we solve questions related to vector space, now let me define what is a subspace as well. So let's see what is a subspace. Now before I show you the definition, let me tell you the definition. How simple is this definition? Subspace is basically a subset of the vector space which satisfies all the properties of a vector space. What did I say? You already know what are the conditions for vector space. What is a subspace? It is a subset of a vector space which satisfies all these properties, that is over vector addition as well as over scalar multiplication. Basically, subspace is a subset of a vector space. So have a look at this definition, students. Let S be a non-empty subset of a vector space V over F. So mathematically you can denote that subset as S subset of V. If S is also a vector space over F using the same addition and scalar multiplication operations, then S is said to be a subspace. So let us now, I hope this is very simple. Array, you have a vector space, take a subspace of that subspace is also satisfying all the properties, then that subspace, such subset is now called what? That subset is called subspace. So this term is very, very important. Subspace means just a subset of the vector space which also satisfies all the properties. Come on, let's take certain problems. Determine which of the following subsets of R power n are in fact the subspaces of R power n. So that's the question, and here we have a series of questions like this. So we'll solve them one by one. So let's learn first of all about what is R power n, because this R power n you will like hear very frequently in your examination or in our discussions. So what is this R power n? Students, R denotes set of real numbers. What does R denote? It denotes set of real numbers. If someone says R square, so what are they saying? So They are basically talking about a 2 cross 1 vector, students. Basically they are talking about 2 cross 1 vector. So where there are two components like this. So this takes real numbers, this also takes real numbers. So that's why they are calling this as R2. So we can also call this as 2 tuple vector. We usually call this also as what? 2 tuple vector. Suppose if I say R3, then it's a 3 tuple vector. It has got 3 components. So each component takes real numbers like this, which is basically a 3 cross 1 vector. If someone says R power n, then it's a n tuple vector, students. What is R power n? It's a n tuple vector. So it has got n components like this. So each component is a real number. So that's what is R power n. Now what are they asking? Let's come back to this question. Determine which of the following subsets of R power n are in fact the subspaces of R power n. So it's like they gave a set. Okay, so this description is all about a set. Now we have to check whether this set forms a subspace or not, or is this set a subspace or not, in simple words. So how do you check? Now checking for R power n would be difficult. R power n means you have to imagine n tuple vector. So now what I'll do is I'll simply set the value of n as 3 students. So basically I'm looking at a 3 tuple vector. So yes, you can do this kind of analysis. There is nothing wrong in this. Let's look at a 3 tuple vector. Now, like I said, this talks about set of vectors. Now, how are those set of vectors, students? So look at this. It is containing set of vectors such that the first component is always greater than or equal to 0. Students, you are all new to this kind of description. So I'll explain them clearly. What is this? It contains set of vectors such that the first component is always greater than or equal to 0. So for example, let me create a 3 tuple vector like this, 1, 2, 3. Does this belong to V? Let's call this entire set as V. Does this belong to V? The only thing that I need to check is what is the first component. What is the first component? The first component is 1, which is clearly greater than or equal to 0. Yes, this vector. So let's name this vector as V1. V1 clearly belongs to the given set. So let me create another vector, let's say V2, let's say -2, 1, 0. Will this belong to the given set? Let's check. So for that, what you need to do is you need to look at the first component. What is the first component? -2. Now what are they saying? The first component has to be greater than or equal to 0. Clearly the first component is not greater than or equal to 0. So you can say that this does not belong to V. So all this activity is to tell you what kind of vectors are present in a given set. Now what are we supposed to do? We have to check whether this forms a subspace or not. So how do you check that? Like we said, if V1 belongs to this set, then minus V1 should also belong to the given set. Let's examine what is minus V1. So what is minus V1? It contains elements like -1, -2, -3. So this is minus V1. Will this be part of this set? How do you check it? Come on, relax. Will this be part of this set? For that, what I need to do is I need to check the first component, students. What is the first component? -1. Clearly, if you want a vector to be part of this set, the first component must be greater than or equal to 0. Now this is not obeying that. Therefore, minus V1 does not belong to V. That means it is clearly not obeying one of the property here. Like we said, if x belongs to V, then minus x also should belong to V. So that's not happening. So what's the answer? It's not a subspace. So the given set is not a subspace. So I'll write a comment. That's it. Over. Let's go to the next problem. So this problem is about It contains set of vectors such that the first component is always 0. If you want any vector to be part of this set, then you have to make the first component to be 0. So, let me generate some vectors 0, 1, 2. So, again I am taking n as 3 only. So, in almost all problems I will be taking n as 3. So, keep the things simple. Will this belong to the given set, students? Yes. How do you check that? So, for that the first component must be 0. Like they said x1 must be 0 na, like here they said x1 must be greater than or equal to 0, here x1 must be 0. So, this is x2 students, like this is x3 students. So, this entire vector I am naming it as v1. Will this be part of the given set? Of course. So, for example 1, 2, 3, will this be part of the given set, students? Look at the first component. The first component is not 0, so clearly this does not belong to V. This does not belong to V, whereas this belongs to V. So, let me create another quantity, let us say V2. So, 0, 5, minus 6. Will this belong to V? For a vector to belong to the given set, the first component must be 0. Yes, this is belonging to V. If I add V1 and V2, let us see what happens. Let me add V1 and V2. So, V1, V2 clearly belong to V. Let us add V1 and V2. What do we get? So, 0 plus 0 is 0, and then you have 6, and then you have minus 4. Is a new vector also belonging to the given set? That is what you need to verify. Is the given vector also belonging to the given set? If you want this to be a part of V, then what is the condition for this particular problem, students? The first component must be 0. The first component must be 0. Yes, this also belongs to V. So, looks like the first condition is satisfied. Like you take any two vectors in the given set. Now, some students might take this kind of vector 1, 2, 3. Sir, you take 1, 2, 3. No. You have to take those vectors which are part of the set. Now, do not try them. You cannot take a vector like this also, minus 1, minus 2 and 3. You cannot take, because the first component is not 0. This also does not belong to V. You do not try that. Take any two vectors from V, add them, the new vector is also part of V. Will the 0 vector be part of V? Let us check 0 vector. 0 vector means it contains all zeros. Will this be part of the given set? How do you verify that? The condition is that if you want this vector to be part of this, the first component must be 0. Yes, it is satisfying that. Yes, it is a part of the given set. So, V1 plus V2 is belonging to V. 0 vector is part of the given set. What about minus V1? Let me check. So, what is minus V1 in the present question? So, it is minus 0, which is 0, and then minus 1, minus 2. Is this part of V? Yes. If you want any vector to be a part of V, then the first component must be 0 here. First component is 0. You can also verify with minus V2. What is minus V2? 0, minus 5 and then 6. Yes, this is also part of V. So, almost all properties are satisfied. Like I said, these are the most important ones that you need to check. If you want to check alpha x, yes, you can check that. For example, what would be alpha into V1, students? Alpha into V1. Alpha into 0 is 0, and then alpha and then 2 alpha. Yes, this is also part of V. So, all the conditions are satisfied, hence the given set of vectors forms a subspace. What's the answer? Yes, it forms a subspace. Let's write that. It is a subspace. Let's solve few more questions like this. Surprisingly, there was one question in GATE D8 2024 paper. I will also solve that question. For that you need some knowledge. Now, what are they saying here? They are talking about some set of vectors such that x1 into x2 must be 0. You create vectors in such a way that when you multiply the first two components, the answer must be 0. Let me create certain vectors 1, 0, 2. Will this be Part of V? Of course. Because what is 1 into 0? 1. The first component to the second component is clearly 0. Let me create another vector 0, 5, 10. 0, 5, 10. Is this part of the given set? Of course, it's a part of given set because what is 0 into 5? 0 into 5, 0 into 5 is 0. Definitely, this is also part of the given set. This is also part of the given set. If you want this set to be subspace, then it has to satisfy all the properties of the vector space. So, like what? Suppose if I add V1 and V2, let's see what do we get. If you add, so what is 1 plus 0? 1. And then 0 plus 5, 0 plus 5, 5. And then what is 2 plus 10? 12. Now, is this part of the given set? How do you check? If you want this vector to be part of the given set, then you have to multiply these two components. What is 1 into 5? 1 into 5 is 5, which is not equal to 0. Therefore, this vector is not part of the given set. Like we said, you take two vectors from the given set. When you add, the new vector should also be part of the given set. The new vector should also be part of the given set, but this is not satisfying that. Hence, this set is not a subspace. Not a subspace is the answer. Not a subspace. Let's try a few more problems. Here, what are they saying? It is again containing some set of vectors such that summation j from 1 to n xj is 1. Meaning by when you add all the components, that answer must be 1. Only such vectors are present in the given set. Let me try some examples here. Let's say V1 is 1, 0, 0. Will this belong to V? Of course, this belongs to V. Sir, how do you say that? You add na, 1 plus 0 is 1. Yes, it's a part of the given set. Now let me take another simple vector like 0, 1, 0. Will this be part of the given set, sir? Yes, sir, it will be part of the given set because when you add, again you are getting 1. So clearly this also belongs to V. Now what about V1 plus V2? 1 plus 0 is 1, 0 plus 1 is 1 and then 0. Is the new vector also part of the given set? Is the new vector also part of the, no, it's not a part of the given set. So because when you add 1 plus 1 plus 0, it is 2, but we want 1. Clearly this does not belong to V. So if V1, V2 belong to V and V1 plus V2 does not belong to V, then it is not a subspace. It's not a subspace. So let's write that comment, not a subspace. Although I can easily eliminate like this, 0, 0, 0. 0 vector should be a part of the given set, I said. 0 vector should be a part of the given set, but 0 vector is not in our given set. Sir, how do you say that? According to this, when you add all the components, that sum should be 1. Now look at the 0 vector. When you add all the components, it's not 1, it is 0. So when 0 vector is not part of the given set, then that set won't be a subspace. That set won't be a vector space. So that's also you can verify. And finally, we have solved this question. Let's look at this. You take set of vectors such that when you add all the components, it should give you 0. Let me try. Let me take V1 as 1, 0. Okay, so the sum should be 0, na? Okay, so let me try like this, 1 minus 1, 0. So like I said, to solve these problems, I am taking 3 tuple vectors for verification purpose. So will this belong to V, students? Of course, it belongs to V. How do you say that? Come on, add this 1 minus 1, 0. When you add, you are getting the sum as 0. Yes, this is a part of V. Now let's look at V2. Let's take some other 1, 2, maybe minus 3. So when you add all this, that sum must be 0. How much should be the sum? 0. Come on, try this. 1 plus 2, 3. 3 minus 3, 0. Of course, this also belongs to V. I have taken two vectors which belong to the given set. Let me add. The new result should also belong to V. So let's add what is V1 plus V2. It would be interesting. 1 plus 1 is 2, minus 1 plus 2 is 1, and then 0 minus 3 is minus 3. Come on, reply me. Is this new vector also part of V? Of course, it is part of V, students. Come on, add it. 2 plus 1 is 3, 3 minus 3 is 0. It also belongs to V. So, like I said, V1, V2 belong to V, then V1 plus V2 should also belong to V. That's satisfied. What about minus V1? So, what do you think is minus V1, students? Minus V1 is minus 1, 1, 0. Will this be part of V? If you want any vector to be part of the present set, then when you add this components, it should be 0. Yes, it's a part of V, there is no doubt. Let's talk about minus V2. What is minus V2? It is minus 1, minus 2 and 3. Is this part of V? Of course, it is part of V. Is 0 vector part of V? Yes, 0 vector is a part of V. When you add all this, it is giving you 0. So far it has satisfied all the properties. Come on, let's see what is alpha V1. Come on, what is alpha V1? It is alpha and then minus alpha and then 0. Is this part of V? Add it, alpha plus minus alpha plus 0. Yes, it is part of V. What is alpha V2? Come on, check what is alpha V2. It is alpha, 2 alpha minus 3 alpha. Yes, it is also part of V. Add it. Alpha plus 2 alpha is 3 alpha, 3 alpha plus minus 3 alpha is 0. It has satisfied all the properties, hence it is a subspace. It is a subspace. So far the things look very simple. Now let's look at this. Based on this, there was GATE 2024 question. So try to observe this carefully. What are they talking about? They are talking about set of vectors called X. You have to listen to this carefully. They are talking about set of vectors called X such that Ax equal to B. Basically, they are talking about non-homogeneous system, because Ax equal to B represents what? Non-homogeneous system. So, what their set contains? What are the set of vectors in V? It is X which satisfy Ax equal to B. All the solutions which satisfy Ax equal to B is now the given set. I repeat again, Ax equal to B can have infinitely many solutions. When you put all those solutions at one place, that set is given as X for us, and we have to verify is that set a subspace or not. And then they say that A is a M cross N non-zero matrix, B is also a M cross 1 non-zero vector. How do you do this? So let me say like this. Let's talk like this. Let's say V1 belongs to the given set called V, meaning by V1 is a solution. Let's also say that V2 also belongs to the given set. Now, when you say V1 belongs to given set, then it has to satisfy this condition. A into V1 must give you B. Same way, when you say V2 is a part of the given set, then it has to satisfy this. A into V2 should give you what? B. This is what information we have. If you take two vectors in the given set, they will definitely satisfy this. A into V1 equal to B, A into V2 equal to also B. Now, according to the subspace, if V1 belongs to V, V2 also belongs to V, then V1 plus V2 should also belong to V. Let me check that. So, let me check what happens with A into V1 plus V2. Now, when you take A into V1 plus V2, I should again get B, because any vector part of the solution, when you take that vector, multiply it with A into your solution should give you what? B. So, I have added, I got a new vector V1 plus V2. Let's see how much this is going to be. Now, I can multiply them. It will be like A into V1 plus A into V2. So, what is A into V1? A into V1 is B. What is A into V2? It is also B. How much is B plus B? It is 2B. So finally what we have is A into V1 plus V2 is giving us 2B, which is not equal to B. How much we were expecting? A into V1 plus V2, we wanted that to be B, but the answer is 2B, meaning by V1 plus V2, which is a new vector, is not a solution. So in simple words, V1 plus V2 is not belonging to the given set. That's it. Many students confused with this. What are they talking about? I'll once again explain you. Nothing to worry. It is all about the solutions which satisfy Ax equal to B. You all know Ax equal to B represents non-homogeneous system. You take all the solutions which satisfy this condition, you take that and keep that as a set. Now I want to verify whether that set forms a subspace or not. So I have taken one solution from that set. So what happens if I multiply A into V1? Obviously I get a B. I have taken another solution. What happens if I multiply A with V2? Again I get a B. Right? So clearly V1, V2 belong to V. Now according to the rules of subspace or the vector space, if V1 belongs to B, V2 also belongs to V, then V1 plus V2 should also belong to V. Meaning by when I multiply A with V1 plus V2, I should again get B, but I am getting 2B. Therefore, it is not a subspace. So, not a subspace. Students, now what you need to learn is the moment you see non-homogeneous system. Let me first write this. Not a subspace. Not a subspace. Yeah, what did I say? The moment you see non-homogeneous system, you can blindly decide the set of all solutions belonging to a non-homogeneous system will not form a subspace. I repeat this again and again. This question also appeared in GATE 2024 paper. The set of all solutions which satisfy the non-homogeneous system Ax equal to B will not form a subspace. So in the exam you can remember like this. The moment you see non-homogeneous, not a subspace. Non-homogeneous, not a subspace. Okay. So I repeat this again. What are you looking at? You are looking at all the solutions which satisfy Ax equal to B. So that forms a set and you want to verify whether that set forms a subspace or not. And the answer is no, it doesn't form a subspace. The moment I highlighted non-homogeneous, non-homogeneous, do you know what's the next thing? Will a homogeneous system, the solutions which belong to a homogeneous system, will it form a subspace? Can you pause the video? Can you decide your answer? So in some time, I'm going to solve that. So here is the problem. So what is this about? It's about all the solutions which satisfy Ax equal to 0. Will this form a subspace? Let's see. So let's take something like this. Let's say V1 is one of the solution which belongs to V, and let's also take another solution which also belongs to the given set. Now when you say V1 belongs to V, then what is A into V1? So when V1 is a solution, A into V1 will definitely be 0 because we are talking about a homogeneous system. Same way, since V2 is a solution, what is A into V2? It is also 0. Now let's see this. I want to check whether V1 plus V2 also belongs to V or not. So for that, I'll take this A into V1 plus V2. What is A into V1 plus V2? So you can multiply like this, A into V1 plus A into V2. What is A into V1? According to this, A into V1 is 0 plus, what is A into V2? Again 0. What is 0 plus 0? It's a 0. So whatever vector you have taken and when you have multiplied with A, you are again getting 0, meaning by, so what is the meaning? The meaning is that V1 plus V2 also belong to what? V. Earlier that condition was not satisfied, hence we stopped here itself, said not a subspace. Right now this condition is satisfied. Will other conditions also satisfy? Like will 0 vector be a part of this? You can take this A into a 0 vector. What is A into 0 vector? Again 0 vector. So that means what? zero vector is clearly part of our discussion, or zero vector is a part of the given set. What about minus V1? Let's see whether minus 1 belongs to V or not. Let's write like this. What is A into minus V1, students? Since minus is a scale, like you can treat minus as minus 1, you can bring that minus 1 out. Now this becomes A into V1. What is A into V1? A into V1 is 0. So we have minus 1 multiplied with a 0 vector. Minus 1 into what? A 0 vector. How much is this? Again a 0 vector, which means that minus V1 also belongs to V. So you will slowly understand that the set of all solutions which satisfy Ax equal to 0, or the set of all solutions of a homogeneous system forms a subspace. The moment you see homogeneous system, subspace. The moment you see non-homogeneous system, not a subspace. So what shall I write here? Yes, it is a subspace. Which is a subspace? The set of all solutions which satisfy Ax equal to 0, that set is a subspace. It is a subspace, students. So this was asked in GATE DA 2024, students, 2024. So let's see what is this question about. Can you solve this quickly? Let me check. Select all choices that are subspaces of R3. Note, R denotes set of real numbers. Let's read the entire question. So it contains the set of vectors such that it has got three components, x1, x2, x3 belonging to R3, such that x is now alpha into 1, 1, 0 plus beta into 1, 0, 0. Okay. So they described about the first set. Let's look up about the second set or the second option. So second option also contains some set of vectors. How is that set created? That set is created like this: alpha square into 1, 2, 0 plus beta square into 1, 0, 1, where alpha, beta are real numbers. Okay. How is the third set created? It is 5x1 plus 2x3 equal to 0, 4x1 minus 2x2 plus 3x3 equal to 0. Can you recollect something from these equations? I'll give you time, nothing to worry. You take 1-2 minutes time and then try to get the answer. So it is again some set of vectors such that 5x1 plus 2x3 plus 4 equal to 0. So this is the information given. Now we have to identify. Clearly it says select all choices that are subspaces. So it's a MSQ. What kind of question, students? MSQ. Now among those 4 options, I can solve the 2 options. I can simply eliminate 2, or I can decide about the 2 options like this. How, sir? Look at this question, sir, or look at this option. 5x1 plus 2x3 equal to 0, and then 4x1 minus 2x2 plus 3x3 equal to 0. Now what is the left side containing? Sorry, what's the right side containing? 0. Right side containing 0. That means it's a homogeneous system. The option C, you can write this as A into x equal to what? 0. So set of all solutions which satisfy Ax equal to 0 belongs to what? The discussion is about homogeneous system. Just now we said homogeneous system. The set of all solutions of a homogeneous system forms what? Subspace. Therefore, this fellow is a subspace, no doubt about that. Sir, right side 0, sir. In option D, right side 0, sir. Will you decide that as a subspace, sir? Now let us examine that. Now what is the equation? It is 5x1 plus 2x3 plus 4 equal to 0. We always write the constants on the right side. So here is a trick. It is 5x1 plus 2x3 equal to minus 4. What is there on the right side? Minus 4. Clearly the right side quantity is not equal to 0. That means now when you write, even though one equation is given, you can write that as A into x equal to what? B. Meaning by the fourth option is from a non-homogeneous system. Non-homogeneous system, what did we learn here? They are not subspaces. The set of all solutions which are from the non-homogeneous system are not subspaces. so not a subspace. So now among the 4 options, we got a clarity about 2 options. Now let's talk about the other 2. So let me talk about option B, students. Okay, let me talk about option B. It was a fantastic problem. Let's talk about option B. Option B. In option B, how is x created? They say it is alpha square 1 2 0 plus beta square 1 0 1. This is how the vectors are created. For example, let me create a vector by taking alpha equal to beta equal to 1, or maybe simpler things. Let's take alpha equal to 1 and beta equal to 0. It is up to you. Create some simple vectors. Now let's call that vector to be v1. So what is v1, students? Alpha square is 1. So what is left is 1, 2, 0 plus beta square is anyway 0, 0 into anything is gone. So what is this? v1. Clearly, let's say v1, let's say belongs to v. Now what we have learned so far is when you say v1 belongs to v, then have a look at it minus v1. What is minus v1, students? It is minus 1, minus 2, 0. Will this be part of this set? Come on, think of it. Can you get minus 1, minus 2, 0 in this set? Now if you say, sir, yes, sir, we can get minus 1, minus 2, 0 from this, then tell me what are the values of alpha and beta? What values of alpha and beta will give you this? Some students might get excited and they say, sir, put alpha as minus 1, sir. Even if you put alpha as minus 1, what is minus 1 whole square? Minus 1 whole square is 1. So again what you get is 1 to 0 only. That means in this particular discussion, if you say v1 is 1 to 0 as a part of the given set, then you are not in a situation, or you don't have the minus v1, that is minus 2, minus 2, minus 1, minus 2, 0 belonging to v. So this is not belonging to v. Now again some students feel it difficult. Sir, how did you decide? I have created one simple vector. I'm saying minus v1 is not part of this. How did you tell, sir, minus v1 is not part of this? Now you provide me some alpha values, sir. If someone says 1, 2, 0 is a part of v, I can provide you them alpha and beta. You take alpha as 1, beta as 0, you get 1, 2, 0. Same way, can you people provide me the values of alpha, beta which give me the vector as minus 1, minus 2, 0? Such values does not exist. The reason is that you have got alpha square, you have got beta square. Alpha square, beta square. When alpha and beta are real numbers, alpha square cannot be negative, beta square cannot be negative, and you cannot get that minus v1, minus v2 to be part of the given set. That means it is not satisfying the properties of a subspace, not a subspace. Simple. Option B, not a subspace. Now let's look at option A. We don't have any problem with option A, students. In option A, how are the vectors created? How are the vectors created? They are created like this. X is alpha into 1, 1, 0 plus beta into 1, 0, 0, where alpha and beta both belongs to real numbers, it seems. Okay. Now let us create a vector by taking alpha as 1 and beta as 0. You can take any scalars. I am taking some simple vectors. So what is that vector v1? When you put alpha as 1, we get 1, 1, 0 plus 0 into any vector is anyway 0. Clearly this belongs to what? V. Then what is minus v1, students? Minus v1 is minus 1, minus 1, 0. Is this also part of the given set? Yes, sir, it's a part of given set. How did you tell, sir? Or how can you create a vector which is in the given set, sir? You can easily tell that. You can take alpha. I can take any value of alpha, na? So what I'll do is I'll take alpha as minus 1 and beta as 0. What is it vector? It is minus 1, minus 1, 0, which is part of the given set. Now you take two vectors, any two vectors from this you add, the new vector will also be part of that. 0 vector is also part of this. Sir, how do you know that 0 vector is part of the given set, sir? Put alpha as 0, sir, beta as 0, sir. 0 into this vector is 0 vector, sir, plus 0 into this vector is again a 0 vector, sir. Adding 0 vectors will again give you a 0 vector, sir. That means in option A or in the given set of vectors from option A, 0 vector is present. If V1 is part of the given set, minus V1 is also part of the given set. V1 plus V2 will also be part of the given set if you want to verify. So there is no problem with option A, it is a subspace. So if any set is created this way, so you can immediately like look at this alpha square beta square. The moment you see alpha square beta square, not a subspace. The moment you see non-homogeneous system, not a subspace. This is how you eliminate the options. You need not do all this analysis. The moment I saw non-homogeneous system, not a subspace. The moment I saw homogeneous system, subspace. The moment I saw alpha square beta square, gone. If you can observe the things this way, in less than a minute you can solve. So now how can you say? So some people will be saying, sir, alpha in option A, sir, V1 plus V2 will also be part of the given set. How do you say that? That is also very simple thing, students. So already V1 is created like this. What is V1? 1, 1, 0. How is this created? By taking alpha as 1, beta as 0. Now let's create V2 by taking alpha as 0, and beta as 1. So what is V2, students? So when you substitute alpha 0, 0 into this is 0, 1 into this is 1, 0, 0. So clearly V2 is belonging to V. Now students, what is V1 plus V2? You add it, 1 plus 1 is 2, 1 plus 0 is 1, 0 plus 0 is 0. Now I want to know whether this will be part of the given set or not. Definitely this will be part of the given set, sir. It's a part of the given set. How do you know, sir? How do I know is, if I take alpha as 1 and beta as 1, let's see what is that vector. I have taken alpha as 1, beta as 1. So it's 1, 1, 0 plus, I have taken beta as 1. It is 1, 0, 0. How much is this? 2, 1, 2, 1, 0. Is this part of the given set? Yes, I have taken. So alpha equal to 1 and beta equal to 1 is giving me this vector. That means clearly, yes, this is also part of the given set. I have proved that minus V1 is part of the given set. V1 plus V2 is a part of the given set. We have proved that 0 vector is also part of the given set. What else you want? What else you want? Clearly, they all make this set a subspace. It is a subspace. So what is the answer for this MSQ? Subspace. Subspace. What's the answer? A is a subspace, and that homogeneous option is also a subspace. Yes. So select all choices that are subspaces. The answers are A and C. So what's the final comment? A, C.